Hello students, welcome to the class of software engineering. Let us discuss about software maintenance. So what do you mean by software maintenance? It is the process of changing a system after it has been delivered. So as I've told that once the system has been developed, the next stage is to deliver the system to the user. So users can start using the system. And then comes your maintenance phase. So it's nothing but you need to maintain your system. So maintain your system means you have to implement changes to your system or you can modify or it's like updating your system. So it is the process of changing a system after it has been delivered. We have three types of software maintenance. Three types of software maintenance. First one is fault repairs. Second, environmental adaptation. Third, functionality addition. So these are the three types of software maintenance. Let us see into the first one, fault repairs. So you know what are faults? Faults are defects you can tell or errors. So I'll begin with the coding errors. So you know how the coding errors are highlighted. Once they are highlighted, you want to make it correct, isn't it? You need to remove those coding errors. So you start removing those coding errors. So what is the cost here required to remove that coding errors? It is cheap. I can tell the cost is cheap here. But if it is a design error means what all models you have designed that is using UML. So those models, if there are any errors in those models, then you need to correct it. You need to change it. So the cost here is more expensive than your coding errors. The cost is more here compared to coding errors because you have to rewrite your different program components there. You need to redesign there. And one more type of error is requirements errors. So you know that requirements you're specifying at the first stage of your software development. So this is most expensive to repair. Why? Why it is most expensive to repair? Because if you want to change the requirement there, if you're making changes in your requirements, like it's modifying or you're adding a new requirement or some error you're going to correct in the requirements, again you have to change in the design, then you have to change in the coding, then you have to again test your system. So it's a lengthy process and also it's more expensive. So here extensive system redesign is needed. Second one is environmental adaptation. This type of maintenance is required when some aspect of the system's environment, when I talk about system's environment, it's not just the surrounding, I'm not talking about the surrounding, it's the platform, that is what operating system you use or what hardware do you use, or it can be other support software. So other support software also. So you need to see that you have to, this type of maintenance is nothing but you need to see whether your system supports all these. Okay, so if you're making, if you have to maintain your system, isn't it? So the application system must be modified. You have to modify your own application to adapt it to cope with these environmental changes. So if there are any changes in the hardware or in the operating system, you have to modify your application in order to adapt to that environment. Third one is functionality addition. Now this type of maintenance is necessary when the system requirements change in response to organizational or business change. So I've told that as in the market there is business change, isn't it? There is business change. So that's why new functionality needs to be added to your system in order to satisfy the business, in order to satisfy the users, I can tell. So you can add new functionalities to your system. So these are the three types of software maintenance. And we have some terminologies also. First one is corrective maintenance. Corrective maintenance is used to refer to maintenance for fault repair. So first we had discussed about fault repair, that is coding error, requirement error, then design error. So this corrective maintenance, this term is used to refer to maintenance for fault repair. So if you want to do the maintenance regarding fault repairs like coding errors or design errors. Second one, adaptive maintenance. So you are adapting the software to a new environment and adapting it to new requirements. The second one, you have seen environmental adaptation. Third one is perfective maintenance. Perfective maintenance means maintaining the functionality of the system. You're maintaining the functionality of the system. At the same time, you're also improving its structure and its performance. That is perfective maintenance. Okay. Here you can see the maintenance effort distribution. So how it is distributed, the maintenance. So you can see here where is larger distribution, functionality addition or modification. Either adding a new functionality or modifying it. So what is the percentage there? 65%. So it is more. So where the maintenance is being applied more, or where the cost is more for maintaining, that goes into this functionality addition or modification. Remaining are less. For environmental adaptation, it is 18%. For fault repair, it is 17%. So fault repairs are minor because almost coding errors you can clear, even design errors won't be more. Okay, and requirement error also will not be there because you have once you have reached till testing phase, you won't be having such. So where the maintenance is incurred mainly on this functionality addition or modification. So after conducting surveys, as shown in the figure, 65% of maintenance is concerned with implanting new requirements. So 65% of maintenance is concerned with implementing new requirements. 18% of maintenance is concerned with changing the system to adapt it to a new operating system. So 18% goes for which one? Making your system adapt to the environment. And 17% of maintenance is required for correcting the system faults. Why it is more expensive to implement the functionality after the system is in operation than implementing the same during development. So we have a question here. It is been asked that why it is really very expensive, means the cost is expensive to implement the functionality once your system has been developed and put into operation. Okay, then the same functionality which you are implementing during the development. So the cost is high once for implementing a new functionality once the system has been delivered and put into use. So that cost is high compared to the cost incurred during the development stage. So what is the reason for it? First one is team stability. So we'll look into this one. See, you know that the software is being developed by the software development team. So those members are being involved throughout the development phase in order to develop the software. So here once the software has been developed, so their job is only that much, only to develop the software and deliver it. So their work is being done. they will be put into next project where they have to develop the new project. So now it comes in maintaining that system. So who is going to maintain the system? So we have maintenance engineers for that purpose. So that team is only responsible for maintaining the system. So a separate team responsible for system maintenance is nothing but the maintenance engineers. So they will be maintaining the system. They will be overlooking into the system. So here once they get the system which is being delivered, they have to understand the background of the system. Yeah, they need to completely understand what exactly is the system, what functionality does it provide, so what is the design of it, etc. All those things you need to understand it. So what happens is, as they don't have any idea, they have to analyze the requirements, whatever is given, or the design and the code. It takes really a lot of time for them to understand the system. So, before implementing any change to that system, they have to understand the system. And understanding the system is more time consuming for them because they have to understand from the scratch. So, it's not easy to implement a new change or update any change to the system. First, they have to understand the system and its components. Okay. Second one is the contractual responsibility. Contractual responsibility. So initially a contract will be signed between the developer and the customer and the developer, or we can tell the company. Okay. So here contract to maintain a system is separate from the system development contract. So system development contract is between the customer and the developer. But they are telling that the contract to maintain a system is entirely different. So this maintenance contract might be given to other companies, may be given to different company rather than your original system developer. There are chances. So it happens. So keep in mind that the contract to maintain the system is separate from the system development contract. Third one is staff skills. Staff skills. So now we are concerned about the skills of the maintenance engineers there. So now you know that maintenance engineers are not sharp as your developers, isn't it? So because they are inexperienced and they are not familiar with the application domain, whatever you are using, either you are using the different application technologies like CSS, JavaScript, or Python, etc. So they are not familiar with it. So they may not be having sufficient knowledge as of software engineers, I can tell. Correct? Fourth one reason is program age and structure. Program age and structure. So now as programs age, so when the program's age goes on, what happens to the structure we are talking about it? So you try to upgrade the system, isn't it? For every year, if you are trying to upgrade the system or modify the system, then the structure of your system will start degrading because might be initially it might have been a very simple system. When you started implementing some changes to it, it might have become little bit complex. So the structure might have got degraded. Okay, and what happens is it really becomes harder to understand at that stage and modify it further. It becomes harder to understand and modify it. Next, we'll see the maintenance prediction. Maintenance prediction. How do you predict the maintenance? So you can see here in the figure, we have predicting maintenance cost. So we are going to predict about the maintenance cost required. So you can see here what will be the lifetime maintenance cost of the system. Now you have developed a new system. You think that you want your system to be used till 15 years. And what might be the maintenance cost over those periods? What will be the cost of maintaining this system over the next year? So immediate year. So you have developed the system just now and you have to analyze the maintenance cost required for the next upcoming year. Next, predicting maintainability. What parts of the system will be the most expensive to maintain? Now, you know that the entire system is made up of several parts. So, in that, some parts might be very expensive in order to maintain it. So, the charge incurred will be more here. Next, predicting system changes. What parts of the system are most likely to be affected by change requests? So based on the change requests, you're maintaining your system or updating your system or modifying your system. So you need to see which parts will be most likely affected by that change. So that is more important. You need to see what is the probability of the part which has been more affected. Next, how many change requests can be expected? That also you need to see. It's not like go on or do 100 changes. No. You have to see how much your system can bear. So how many change requests it can accept. So this is regarding the maintenance prediction. Now, so we'll see each thing. We have seen all those already. Predict what system changes might be proposed. Predict maintainability, predicting maintenance cost. We will see the examples of process metrics that can be used to assess the maintainability. So we'll see some examples of process metrics. First one is number of requests for corrective maintenance. So you have learned about corrective maintenance. So what is the number of requests for corrective maintenance? An increase in the number of bug and failure reports may indicate that more errors are being introduced into the program than are being repaired during the maintenance process. So this may indicate a decline in maintainability. So what does it mean? See, during the maintenance process, that is, you are going to either modify or update your system, and by observation you get to know that if the number of errors increases, fault or the bugs increases, then they are being repaired, then what happens? There is decline in maintainability. You need not go for maintaining such type of systems. Okay, if the number of bugs or the errors are more than which are being repaired during the maintenance phase, then you have to go for the decline of that system. Second one, average time required for impact analysis. Average time required for impact analysis. So this reflects the number of program components that are affected by the change request. So as I told that you need to see the number of components that are likely to be affected by the change request. Now if this it increases, okay, the time is increasing, then it implies that more and more components are affected. So the maintainability is decreasing, I can tell. Okay, the maintainability is decreasing. Third one, average time to taken to implement a change request. So this is the amount of time mainly required to modify your system. So you have to modify a system means you have to modify its documentation, update its documentation also, after you have assessed which components are affected. So if the time required is more, that also may indicate a decline in maintainability. So an increase in the time needed to implement a change may indicate a decline in maintainability. So if it is very high, the time is more, then there is no use of maintaining such type of system. So I can give a decline for the maintainability. Fourth one, number of outstanding change requests. An increase in this number over time also will indicate a decline in maintainability. Now we'll see about software re-engineering. What do you mean by re-engineering? Software re-engineering. You have studied software engineering. Software re-engineering means reverse engineering. You are re-documenting the system, that is from the beginning. What is that? Your requirements you have framed. So that is your documentation, SRS. You are re-documenting the system. Okay. Then refactoring the system architecture, again changing the architecture of your system. Translating programs to a modern programming language you can do. So you try to translate the program, given program, into a new modern programming language. So suppose you have written the program in C and you want to change to Python. Okay. And modifying and updating the structure and value of systems data. So here you are modifying the structure and also you are changing the value of the system's data. But keep in mind here, functionality of the software is not changed. Data, everything is changed, but functionality remains same. So benefits of re-engineering over replacement. First one is reduced risk. So we'll see the benefits of re-engineering over replacement. Replacement meaning you know. So what is the benefit of re-engineering over replacement? First one is reduced risk. You know what might be the risk in your project, how you have to face it, how you have to overcome it or try to reduce the risk. So there is a high risk in redeveloping business critical software. So there the risk is high. So here errors may be made in the system specification or there may be development problems. So delays in introducing the new software may mean that business is lost and extra costs are incurred. So, so one thing is risk is reduced. So you know that there is high risk in redeveloping business critical software, which is giving contribution to the business. So errors may be made in the system specification or there may be development problems also. But the delays in introducing the new software may mean that the business is lost and extra cost will be incurred. Okay, reduced cost. So the cost of re-engineering. Next we'll see in detail about the re-engineering process. So you can look at the diagram and you can see here there is original program. So you have the original program and you have your source code translation, means you have one source code translation tool available which will convert from one language, that is programming language, to another programming language like C sharp to Java or Java to Python. So then you are doing reverse engineering. So I said that re-engineering means reverse engineering, going back. So what you are going to do is your program documentation. So you are redocumenting, isn't it? So you get a new program documentation. And what is here? You are improving the structure of the program. Improving the structure of the program. So you get a restructured program again. So here you are doing reverse engineering on program documentation again, and here program structure improvement you are doing. So you get a restructured program again. And in program documentation, what do you see that? You get program modularization. Program documentation and this restructuring the program will finally lead to what? Program modularization. So entire program you are dividing into different modules. It will be having different modules. Then re-engineered program. So that re-engineered program will be applied on data re-engineering. You are re-engineering the data. So you have the original data, you are re-engineering that data. So finally what you get? A re-engineered data. So this diagram doesn't go in flow, so you need to analyze it. Okay. So here you're redocumenting the program. So making the program make more modularized. Okay. Then you're also re-engineering the data to get re-engineered data. So we'll discuss about each one. The activities involved in re-engineering process are: first one is source code translation. So we have source code translation I've told here. We have that one. So we have some translation tool where the program is converted from an old programming language to a more modern version of the same language or to a different language. So the original program, which is written in some programming language, that is converted to a more modern version of the same language, or you can convert it to a different language. Second one is reverse engineering after. So in reverse engineering, what you're doing is you are analyzing the program and information extracted from it. Information is extracted from it. This helps to document its organization and functionality. So we are redocumenting its organization, trying to change its organization, make it more modularized. Third one is program structure improvement. So the control structure of the program is analyzed and modified to make it easier to read and understand. So you're changing the structure of the program. So in order to make it more easy to understand it. Next, program modularization. So related parts of the program are grouped together. So you are grouping the related parts in the program, and if there is redundancy, duplication, you can avoid it. You can remove such duplicated data. In some cases, this stage may involve architectural refactoring. What do you mean by architectural refactoring? Example, a system that uses several different data stores may be refactored to use a single repository. Okay? So this is a manual process. And fifth one, we have data reengineering. So I've told. So the data processed by the program is changed to reflect program changes. So here actually you're modifying the data which is being processed by the program. So mainly to reflect the changes. So for example, like in your project, the data will be nothing but stored in the database. So this may mean redefining database schemas. So you have certain structure for your database also. You will be defining it earlier. So that you have to again redefine because you are re-engineering the data. And you can convert the existing databases to the new structure also. Should also clean up the data, that is remove the errors. Also clean up the data. If any errors are there, that also needs to be removed. So this is about re-engineering process. Now, what is the disadvantages of re-engineering? One is there are practical limits of how much you can improve a system by re-engineering. So there are some limits of improving a system by re-engineering. You cannot cross that more than that limit. For example, it's not possible to convert a system written using a functional approach to an object-oriented system. So now the question arises here. So if you have written a program using functional approach, then is it possible to convert it into object-oriented approach? That is difficult. So it's not possible in re-engineering. So that is one of the disadvantage of re-engineering. Next we'll see preventive maintenance by refactoring. Preventive maintenance by refactoring. So what do you mean by refactoring? Refactoring is nothing but making change improvements to your program to actually slow down the degradation. So if your system has been degraded, its structure has been degraded after doing the changes, then you can go for refactoring. So it's the process where you try to improve your system. It means modifying a program to improve its structure. So you're modifying a program to improve the structure of the system. You can also reduce its complexity. If it looks very a complex system, then try to make it into a simpler and also easier to understand. Reengineering takes place after a system has been maintained for some time. So keep in mind, maintenance will happen for a few years and reengineering will take place only after a system has been maintained for some time. So refactoring is a continuous process of improvement throughout the development and evolution process. So refactoring is a continuous process of improvement throughout the development and evolution process. So reengineering will take place after a system has been maintained for some time, and refactoring is a continuous process of improvement throughout the development phase, also evolution phase. So that is the difference between refactoring and reengineering. So reengineering will take place after the maintenance, whereas your refactoring is like you're improving the system. So it can take place in between the development as well as the evolution process. Example of what can be improved by refactoring. Now I told that refactoring is the process of improving your system. But exactly what can you improve? Let us see into it. First one is duplicate code. Duplicate code means same code. So similar code, if it appears, better to remove it and you can implement it as a single method or function. Okay, and just call that function wherever you are using in that program. Long method. Suppose your method is very lengthy. Then you redesign it into shorter method. Third one, switch or case statement. So you all of you know that how to use a switch statement. So these often involve duplication where the switch depends on the type of some value, no? So based on that value, your control will be transferred to that particular case block. The switch statements may be scattered around a program. Yeah. So if suppose I have used somewhere a switch block, okay, I might be calling it anywhere in the program. That switch I might pass the value. So the switch statements may be scattered around a program. In object-oriented languages, you can often use polymorphism instead of that polymorphism to achieve the same thing. To achieve the same thing. So these are the examples. One more is data clumping. What do you mean by data clumping? See, data clumps you have occur when the same group of data items. See, data item means here your data is field or it can be parameter. Okay, so we are not taking a data means here it's not a function or method. Keep in mind here when I tell data, it is fields or it is parameters. So data clumps occur when the same group of data items reoccur in several places in a program. So same group of items, data items like fields or parameters are occurring in several different places in your program. So these can be replaced with an object encapsulating all of the data. Okay, speculative generality. This occurs when developers include generality in a program in case it is required in future. So this can often simply be removed. So these are the examples of what can be improved by refactoring. Now we'll discuss about legacy system management. So I've told about what is legacy system in my earlier sessions. Legacy systems are old systems, already existing systems. Okay, so now how to perform this evolution of this legacy systems? How to maintain? How to evolve those legacy systems? So you have to decide the following strategies for evolving legacy systems. So there are certain strategies for evolving evolution process of your legacy system. So you have to assess your legacy system and you have to decide whether you can use it or just throw it. So you need to come to a decision, isn't it? First one, scrap the system completely. You know the meaning of scrap. So this option, when you have to choose is, suppose that legacy system is not making any contribution to the business, then you can scrap such systems. Okay, clear? So they are no longer in use. That's why you can scrap such systems. So this option should be chosen when the system is not making an effective contribution to business processes. Okay, so they are no longer making any contribution. So there is no effect in that. Second one, leave the system unchanged and continue with regular maintenance. So you're not going to scrap the system here. Leave the system unchanged means you're not going to make any changes and you're continuing with your normal maintenance process. So this option should be chosen when the system is still required. So that means that your system is still required but it's stable and you can make only few changes. Regular maintenance is normal maintenance. So few change request it can accept. You can make but not many. Yeah. Third one, re-engineer the system to improve its maintainability. Okay? Re-engineer the system to improve its maintainability. Now, this option should be chosen when the system quality has been degraded by change. So I told that once you start doing changes to your system structure degrades. So when the quality of the system has degraded, it's better for going for this option, re-engineering. So when you can choose re-engineering when the structure of your system has degraded, so you can improve that program structure or the quality of your system. So do the re-engineering. This process may include developing new interface components so that the original system can work with other newer systems. So in this process, what you're doing is you're developing new interface components that which you can make to work it with the original system. Okay, so you're going to develop some new interface components which you're making it to work with the original system. Fourth one, replace all or part of the system with the new system. So here, replace all or part of the system with a new system. This option should be chosen when factors such as new hardware, so some new hardware you think, mean that the old system cannot continue in operation, or where off-the-shelf systems would allow the new system to be developed at a reasonable cost. So suppose you think some hardware unit you feel to replace it, that is you can replace, okay, in your old system, or replace all means you are doing a new system, developing a new system. Okay. Now when you're assessing a legacy system, one needs to look at it from business perspective and technical perspective. So if you want to assess, how will you assess your legacy system from two perspectives? So you have two views. One is from business perspective point of view. Another one is from technical perspective point of view. So keep in mind how you're going to assess the legacy systems. You're going to assess the legacy systems from two perspectives. One is the business perspective, means how much it is making contribution to the business, or whether how much you can decide whether or not the business really needs your system. So you can decide whether or not the business really needs the system. And technical perspective also we need to see.
So from a technical perspective, what you are going to see is one need to assess the quality of application software and the systems support software and hardware. So from business perspective, I've told that what you will decide is whether your system is really satisfied or really it's gonna make contribution to the business. And from technical perspective, you're going to assess the quality of your application, that is main thing. And also if there are other support software tools, that also you can assess. Then you have to use a combination of the business value and the system quality. So you have to use a combination. So you have to see that one business value you have to take and quality to inform your decision on what to do with the legacy system. So based on these two parameters, business value and quality, keep in mind business value and quality, you have to decide what to do with these type of legacy systems. So we'll take one example now. For example, assume that an organization has 10 legacy systems. So they have 10 legacy systems. Legacy systems are old systems. Now what will you do? Whether how much you will retain in that one, let us see. So how to assess all those 10 legacy systems? So I told that you have to see from business perspective and technical perspective. Business perspective, technical perspective. So you have to assess two things here. One is the business value, another one is the quality. So and then based on that you have to judge. So we have a chart here. You may then create a chart showing relative business value and system quality. So you can see this. There are 4 clusters now in your system. So your organization has 10 legacy systems. So just see how your entire system is divided into 4 clusters. How your entire system is divided into 4 clusters. This is first cluster, second one, third one, fourth one. Okay, let us see the y-axis. On the y-axis you have business value. On the x-axis you have system quality, as I told them. So one is quality you're seeing, another one is the business value. So on the x-axis you have the system quality, on the y-axis you have the business value. So you have 4 clusters. You have 4 clusters. Now just we'll look at the first cluster. In that how many systems are there? Legacy systems 3. 1, 2, 3, and it indicates low business value, low quality. Next second cluster, you have 2 systems, 4 and 5. It is low business value, high quality. Next in third cluster, you have 6, 7, 8. That is high business value and high quality. Next in the last cluster, you have 9 and 10, high business value and low quality. Okay, so we will see what each cluster indicates. First one will take low quality, low business value. So you have here low quality, low business value. So what does it indicate? Quality is also low, business value is low. Now first we'll discuss about low business value. Means that legacy system is not making any contribution to the business, correct? Yeah. So in such cases you have to scrap such systems. In such cases you have to scrap such systems. So keeping that systems in operation will be more expensive, so it's of no use, so better to scrap such systems. Next, second one, low quality, high business value. You can see here low quality, high business value. So it's making some, your legacy system is making some contribution to the business. Okay. So you cannot scrap that system. So they cannot be scrapped. But the quality is low, no? Quality is low. So quality is low means obviously it is very expensive to maintain such systems. So
What will you do to improve the quality of the system? Already I have told, do re-engineering. So here the quality of the system is low, which indicates that it's very expensive to maintain such type of systems. So to improve the quality of your system, go for re-engineering. So these systems should be re-engineered to improve their quality. Next, third one is high quality, low business value. Here, high quality, low business value. So, low business value means they're not making much contribution to the system, but thing is high quality. No, high quality. So, they may not be very expensive to maintain. It is not worth replacing these systems. So, normal system maintenance may be continued. So idea here is low business value means it's not making effective contribution to your business. Correct? But the quality is high here, so it's not expensive to maintain them. But it's not worth replacing these systems. No need for replacing these systems because you know that quality is good already. So normal maintenance only you can continue. If expensive changes are not required and the system hardware remains in use. If expensive changes become unnecessary, then the software should be scrapped. Okay. Fourth one, high quality, high business value. That is the fourth cluster, high business value, high quality. Here the legacy systems, they are making good, effective contribution to the business as well as the quality of these systems is good. So we can decide that these systems should be retained, should be kept in operation. Okay. So normal system maintenance you can continue for it. Normal maintenance is enough. Let us see the factors used in environment assessment. So in bracket it is given as business perspective. So what are the factors used in environment assessment? We are seeing in the business perspective point. So the factor one is supplier stability. Now, thing is, you need to maintain your legacy system. So, to maintain it, you need the raw materials or the resources. So, it is the supplier who provides it, isn't it? So, you need to see, is the supplier still in existence? Is the supplier still in existence or not? And you have to see also, is the supplier financially stable or not? So you need to see whether the supplier is financially stable and likely to continue in existence. So he might continue. You need to see that one. And if the supplier is no longer in business, suppose he has stopped giving the materials, then you need to see whether anyone is there, anyone else is there to maintain the system. So does someone else maintain the systems? So you need to see that one. So that is supplier stability. So first you have to see whether the supplier is still in existence. Okay. If if not in existence, then you have to see someone else for maintaining the system. Failure rate is the second factor. Does the hardware have a high rate of reported failures? So your system will be made up of several other units. So those might be your hardware units also. So you need to maintain those hardware units. So you need to see that what is the rate of failure rate of those hardware units. Does the support software, now we have seen the hardware, does the hardware have a high rate of reported failures? You need to see. Now when you come to the software, does the support software crash and force system restart? So this is related to your support software for your application. So whether is there any chance that it crashes and again you have to restart your system. So you need to see all those things. Next, age. How old is the hardware and software? So both units are there, hardware and software. How old it is, you need to see. The older the hardware and support software, the more obsolete
it will be. It may still function correctly, but there could be a significant economic and business benefits to moving to a more modern system. So you are going to see the age of your hardware and software. So thing is, you know that the older they become, they are not going to have that much effectiveness. So they might function correctly still, but they are not having much effectiveness. So you have to see whether you need to move to a modern system. So try to change those softwares or hardware. Next factor, performance. Performance. Is the performance of the system adequate? Now this is more important. Okay, so you have to see earlier, once your software has been built or system has been built, you know the performance of your system. So later, as years go by, you have to see the performance, whether it has declined. You need to see that one. Do performance problems have a significant effect on system users? Next one is the support requirements. Support requirements. What local support is required by the hardware and software? You need to see what local support is required by the hardware and software. So if there are high costs associated with this support, okay, it may be worth considering system replacement. So that is support requirements. So first you need to see what local support is required by the hardware and software also. Now if there are high cost, if the support is really of high cost, then it may be worth considering system replacement. You can go for replacing the system. Next is the maintenance cost. Next factor is the maintenance cost. So here you need to see what is the cost of your maintaining the hardware units, and also what is the cost of your support software licenses. So some licenses might be purchased one. So what is the cost you need to see? Older hardware may have higher maintenance cost than modern systems. Support software may have high annual licensing cost. Next is interoperability. Interoperability. So interoperability. You need to see that each component uh, operates correctly in coordination with other component. So are there problems interfacing the system to other systems? So you need to see the interface between them, between each component, whether it is working correctly or not. For example, be used with the current versions of the operating system, is hardware emulation required? Next, we'll see the factors used in application assessment. What are the factors used in application assessment? So that is from technical perspective, you need to see it. From technical perspective. So first factor is understandability. Understandability. So how difficult is it to understand the source code of the current system? So you need to see understandability means you need to know that how difficult it is to understand the source code of your system. How complex are the control structures that are used? You will be using different control structures in your program. So how complex are they? Do variables have meaningful names that reflect their function? Now we have used several variables. Imagine you have used several variables in your program, and the variable has different meaning. If it has a meaningful meaning that will actually show their functionality, it's more better. Next is documentation. So what system documentation is available? What system documentation is available? Is the documentation complete, consistent and current? What system documentation is available? So you need to see for the documentation part in your system. So whether the documentation, that is your SRS, is being available. And then you have to see, is the documentation complete?
Complete in the sense it has all the requirements, either functional requirements, non-functional requirements, then what? Design, design models, all those are there. Architecture of your system, everything you need to see. So is the documentation complete, consistent and current? And it is current, not so many years made. It is previously made so many years. Next, data. So, is there an explicit data model for the system? So, you need to see whether there is an explicit data model for your system. So, you have some data models you have used, isn't it? So, to what extent data models like your database schemas, all those, okay? To what extent is data duplicated across files? So, you need to see that data or the raw material, isn't it? So the data is being duplicated in different files. So you need to look for that one. Is the data used by the system up to date and consistent? And also you need to see that whether the data used by the system is up to date and consistent, current, you need to see. Next is the performance. Performance. Is the performance of the application adequate? So as I've told previously about the performance of the hardware, whether, performance of the system is adequate, you can see here, isn't it? So here we are seeing performance of the application of your app is adequate or not. Do performance problems have a significant effect on system users? So do that performance problems which are there, they have a significant effect on system users. Next we'll see the programming language. So you will be using certain programming language. Are modern compilers available for the programming language used to develop the system? Okay, so you need to see that the modern compilers, okay, so you use the compilers to run your system. So whether those modern compilers are available for the programming language in order to develop the system, Is the programming language still used for new system development? So if your system is new and you want to use the same programming language, you need to see that whether you want to retain the same programming language or not. Next is the configuration management. Configuration management. So what do you mean by configuration management? As you know that it's nothing but maintaining the different versions, maintaining the different versions of the system, maintaining the different versions of the system. So you need to see that are all versions of all parts of the system managed by a configuration management system. So you are seeing are all versions of all parts of the system are being managed by a configuration management system. Is there an explicit description of the versions of the components that are used in the current system? So since you are using a current system, whether you need to see that all the versions details are specified or not, you need to see. So is there an explicit description of the versions of components that are used in the current system? Okay. Next, factor test data. Now test data is where you are supplying during the testing process, isn't it? Test data. So does test data for the system exist? You need to know that whether the test data is available for your system. Is there a record of regression tests carried out when new features have been added to the system? So this is related to your testing process, no? Related to your testing process. So you need to see that whether the test data is available or not for your system, and you have to maintain a record of regression test. So when this regression test should be carried out? Whenever a new feature has been implemented or a new increment has been developed. Okay, so that is the test data.
So does test data for the system exist? You need to see first, and you need to see whether the record of regression test is being maintained when new features or new increment is being added. Next is the personal skills. Personal skills. So personal skills, when I talk, the people who are working in that maintenance phase. So you need to see that are there people available who have the skills to maintain the application. So you need to see whether the people involved in maintaining that application have the skills. They have actually the skills or not. And you need to see that whether these people have experience with the system. That means whether they have already got any experience with the system, they know about the system documentation or system structure, or it can be systems program also, programming code. Okay, so you need to see that whether the people who are maintaining the application are skilled or not, and also they have some experience with the system or not.